Look at finding x-intercepts of a quadratic when we're in vertex form. And this is our vertex form. Vertex. It is written as normally f at x is equal to an a value which deals with stretches and compressions, x minus h which deals with horizontal translations, and plus a k value which deals with vertical translations, right? And a common way to maybe do this is to think that, oh, I'll take my vertex form to standard, right? And then I can factor my standard form to figure out x-intercepts, which is common, and you got to go through all three forms that way, which is fine. It's good practice, but there is a faster way to find x-intercepts from this. Remember, an x-intercept is when the y value is 0, right? So if we have our graph, our x-intercepts are when our when y is equal to 0, when it's crossing these points. So maybe doing something like that for all we know. So in factored form, it's really helpful to be in that form. Standard form is really no good for finding that. We have to, but it might be the in-between for moving. What's good about vertex form, okay, the y value is the f at x. So let's replace f at x with 0 is equal to our vertex form. What's really good about vertex form is, and this is the reason standard form is really no good, is that there's only one variable in vertex form, which means we can isolate for this one variable, right? When we're in standard form, and I'll write it over here on the side, maybe in red, standard. Okay, standard form, you have f at x is equal to ax squared plus bx plus c. And what becomes difficult in standard form is that you have an x squared and an x, so you can't even really combine these. It becomes really difficult to isolate the variable, and that's why we factor and put it into factored form. So in vertex form, we can isolate. If you recall isolating variables, one common thing that they refer to is like reverse BEDMAS. So the first thing I want to move over is my -5. I want to move it to the other side. And when I move -5 to the other side, you know what it'll become?
Positive?
Yeah, so 0 plus 5 is just the number 5, right? So we have 5 is equal to 2x minus 3 squared, okay? The next step is our multiplied by 2 on this side. If we want to move it over to the other side, what do we have to do?
Divide.
That's right, we need to divide. So we'll divide that by 2. So I can leave it as a fraction, or I can put it as 2.5. So since you're probably stronger with decimals, let's do decimals. And what happens over here, essentially what we do is divide both sides by 2 so they create a 1 or cancel out. And you're left with x minus 3 squared. Okay, so here's what the next step is. The next step is we square root this value. Okay, so when we square root this, we've got to technically square root both sides, just like how we divided by both sides. And when we square root both sides, we're going to be left with 2 answers, because there's 2 answers to the square root of 2.5. Let me 2.5 root it. Oops, wrong order there. The root of 2.5. 1.58 we'll round it to. Okay, so we have 1.58, and it's technically the positive and the negative value of that. We have positive and negative 1.58, and technically on this side, so the square root and the power of 2 essentially create a power of 1, which really doesn't do anything, so you could, sometimes they call that canceling out. So you're left with x minus 3, and the idea is you've kind of technically square rooted this side also, right? And when you, actually from this case that we don't have to talk about it, so this works out great. We have a positive and a negative of 1.58, so we'll skip that other idea, which means we have 2 answers from here. Okay, so what we're going to do is we split it. Just like in most, when we use quadratic formula or we factor, we're going to end up with 2 answers. So we have x minus 3 is equal to positive 1.58, and x minus 3 is equal to negative 1.58. Okay, so we're going to isolate for x in both of these equations. So x is equal to 1.58 plus 3, and x is equal to negative 1.58 plus 3. And what it'll do here is x equals 4.58. And over here, we're going to get x is equal to, I think 1. 1.42. I think that's it. We can probably check with the calculator. But those would be our two x-intercepts. Okay, so instead of going all the way to standard form, we can technically just isolate for our vertex form, and that'll be our two roots in this question. And being our two answers, 4.58 and 1.42, quickly go to our graphing calculator, and we see they get 4.581, and remember we rounded a little earlier, and 1.419, which roughly rounds to 1.42. So we were right, and that was the equation we used. Okay, so this kind of be the shortcut method to it.